Hi, thanks for joining me. I want to zero in on a very narrow class of chemical reactions called anhydrides. This is especially important for those of you who are in IB chemistry. It's not something that's typically covered in Chem 1 in high school nor in AP chemistry. So this is just for those IB students, or maybe in Gen Chem you have teachers who cover those. Anhydride, an means without. So an anhydride means a substance without water. And the reaction involves adding the water back into the compound, so to speak. So this is a subset of a synthesis in this case. So acidic anhydrides are non-metal oxides plus water, and they're going to yield acids. So a good example is CO2 in water. Now, if we assign oxidation numbers, the C in CO2 has an oxidation number of +4. The oxygen is a -2. The hydrogen in water is +1, -2. In H2CO3, we have H2CO3. The oxygen's -2, the hydrogen's +1, and the carbon comes out to be +4. So you notice this is not a redox reaction. It would take like multiple steps for oxidation reduction to occur. So when I have my students predict them, I predict them as if they are not redox reactions. So if I take water plus P2O5, I know I'm going to make an acid, and hopefully you realize that it's going to be based on PO4 or PO3, 3-. I would certainly give those two a shot. I would start with phosphate. So let's look at the oxidation number there. I've got 2 phosphorus. I don't know its charge. I have 5 its oxidation number, excuse me. 5 oxygens, it's -2, and that's got to be a 0. So if I solve this for phosphorus, I find that phosphorus has to be +5 oxidation number. So let's take a look at each of these and see which would give us that +5. So phosphate has 1 phosphorus. I have 4 oxygens at -2, and I have a leftover charge of -3. In phosphite, I have 1 phosphorus plus 3 oxygens at -2 is equal to -3. So hopefully you can see from this that the phosphorus here is +5, and the phosphorus here has an oxidation number of +3. So we're going to choose the acid that would have the +5 oxidation number. So when we add water and P2O5, it means that the acid that forms is H3PO4. Okay? Now, an alternative way to doing that is that you know your phosphorus polyatomic ions have 3 H's to balance the 3 negative charges, and we can solve for our number of oxygens. So 3 hydrogens, they're each +1. I have to keep that phosphorus at +5, and then I have X number of oxygens at -2, and that has to be 0. And you'll find indeed that X comes out to be 4. So you can do it kind of trial and error or use an algebra to try to determine that. The basic anhydrides are a little simpler than that. We're going to make hydroxides. So if I have sodium oxide plus water, metal oxides make bases, NaOH, and that's it. Sorry, NaOH. And now I have to balance it. So I'd need a 2 there. Whoops. No, I had my eraser there. 2, NaOH. So that one's much more straightforward. So hopefully this helps you a little bit. I know these, especially these acidic anhydrides, are challenging. So you may want to memorize some of your common ones like Nitrogen is likely to be nitrate or nitrite. Sulfur, we have the sulfite ion or the sulfate ion. So you can often figure it out just by knowing your common polyatomic ions for your acidic anhydrides. So thanks for joining me and good luck.